A breaking news. NASA is still receiving a signal from a machine that should have gone silent more than 40 years ago. The signal is coming from beyond the edge of our solar system. It takes almost an entire day to reach Earth. And the strangest part is not that Voyager 1 is still alive. The strangest part is what it has been detecting out there, a persistent signal in the plasma between the stars. A signal that is revealing that interstellar space is not the quiet, empty void scientists once imagined. And now, after nearly 50 years in space, Voyager 1 is slowly running out of the power that keeps it alive. Every year, another instrument has to be shut down. Every year, the spacecraft gets weaker. And sometime in the coming years, humanity will receive the final message from the oldest explorer we have ever sent into the darkness. But before that happens, Voyager the 1st of May still have something extraordinary left to tell us, because NASA did not expect to hear this signal. And the deeper Voyager traveled into interstellar space, the more obvious it became that the universe beyond our solar system was not behaving the way scientists thought it should. To understand why that matters, you have to understand what Voyager 1 was never supposed to become. September 5, 1977. A rocket launches from Florida carrying a small spacecraft built with technology that, by today's standards, seems almost ancient. The spacecraft is called Voyager 1. Its mission is not supposed to last forever. In fact, its original mission is remarkably simple: visit Jupiter, continue to Saturn, take photographs, collect scientific measurements, then eventually stop working. The engineers who built Voyager 1 expected it to survive for a few years, maybe 4, maybe 5. Nobody was planning for a machine that would still be transmitting data almost half a century later. Nobody expected it to become the farthest human made object in existence, and nobody expected it to become the first machine ever to enter interstellar space. But Voyager 1 had one extraordinary advantage: it kept going. It passed Jupiter in 1979, then Saturn in 1980, and with every planet it passed, it expanded the boundaries of what humanity knew about the outer solar system. But the planets were not the final destination, they were only the beginning. After Saturn, Voyager 1 continued outward. The Sun became smaller behind it. The distance between the spacecraft and Earth became almost impossible to imagine. And eventually, Voyager reached the boundary that separates the solar system from the space between stars, the heliopause. Now, this is where the journey becomes important. The Sun is not simply a ball of light sitting in the middle of empty space. It constantly releases a stream of charged particles called the solar wind. That wind travels outward in every direction. It passes the planets. It continues beyond the outer solar system, and eventually it reaches a region where it begins to collide with the material and magnetic environment of interstellar space. The solar wind pushes outward, the interstellar environment pushes inward. The result is a massive invisible boundary, the heliopause. Inside that boundary, the Sun dominates the environment. Outside it, Voyager would enter the space between stars. For billions of years, no human object had ever crossed that boundary. Then, in 2012, Voyager 1 did. Think about what that means. For the first time in history, a machine built by human beings was no longer simply exploring the solar system. It had entered interstellar space, the space between stars, a region no human being has ever physically visited, and then Voyager continued transmitting. That alone was extraordinary. But what Voyager began detecting after entering interstellar space was even more important. Scientists had expected the region beyond the heliopause to be thin, cold, and relatively quiet, not completely empty. There are particles, there are magnetic fields, there is radiation. But compared with the violent environments around stars and planets, interstellar space was expected to be relatively calm, a vast cosmic emptiness. Instead, Voyager 1 began detecting a persistent plasma emission, a faint but continuing signal, not a one time burst, not a sudden explosion. Not something that appeared once and disappeared, a signal that continued and continued and continued. This was the moment the story changed, because the space between stars was beginning to look less like an empty void and more like a physical environment with structure, movement, and activity. Voyager was not simply passing through nothing, it was moving through something. And the more data scientists received, the more complicated the picture became. The signal was connected to the plasma surrounding the spacecraft. Plasma is a state of matter made up of charged particles. It exists throughout the universe. It is found in stars, in solar winds, in cosmic environments across enormous distances. And Voyager 1 was now measuring plasma directly from interstellar space. This was something humanity had never done before. Before Voyager, scientists had to study interstellar space from the outside. They used telescopes. They measured radiation, they studied distant objects, they created mathematical models, they made predictions about what the environment between stars should look like, but a model is still a model. There is a difference between predicting what an ocean should be like from the shore and placing a sensor in the middle of that ocean. Voyager 1 was the sensor, and the measurements it was sending back suggested that the space between stars was more complicated than expected. It had structure. It had variations, it had disturbances, it was not a perfectly smooth, silent background. And this is where the title of this story becomes important. NASA did not hear a message from an alien civilization. Voyager did not discover a mysterious voice. The signal was not a secret transmission from another world. The real mystery was more subtle, and scientifically, that may make it even more important. Voyager was detecting something that existing models did not fully explain, a persistent emission in the interstellar plasma, something that could provide information about the density and behavior of the environment surrounding the spacecraft. And scientists were left with the question: what exactly was producing it? Was it the natural vibration of plasma particles? Was it a form of quasi-thermal noise? Were scientists observing a process that could fit within existing theories? Or was the signal revealing that the models used to describe interstellar space needed to be changed? The answer was not immediately clear, and that uncertainty is exactly what makes the discovery valuable. Because science does not advance when every observation confirms what scientists already believe. Science advances when reality forces scientists to ask a better question. Voyager 1 was doing exactly that, but the plasma signal was only one part of the mystery. Because the boundary Voyager had crossed was also far more complicated than expected. For decades, scientists had imagined the heliopause as a transition between two different environments. On one side, the solar wind, on the other side, interstellar space, a boundary between the influence of the Sun and the wider galaxy. But Voyager's measurements revealed that the region was not simply a clean wall. Particles were interacting, magnetic fields were interacting, energy was moving through the boundary, and the relationship between the solar system and the environment surrounding it was more dynamic than many models had suggested. This matters because the heliosphere is not just an interesting scientific border, it is part of the cosmic environment that surrounds Earth. The Sun's magnetic influence and solar wind create a vast region around the solar system. That region interacts with high energy particles traveling through the galaxy. Some of those particles come from violent cosmic events, exploding stars, extreme stellar environments, powerful sources of radiation. The heliosphere helps reduce the amount of certain high energy particles that reach the inner solar system. So, when Voyager shows scientists that the environment around the heliosphere is more complicated than expected, it is not simply telling us something about a distant region of space. It is telling us more about the cosmic environment surrounding our own planet. The shield around our solar system is not a simple wall, it is dynamic. It responds to the environment around it, it interacts with the space beyond it, and Voyager 1 is one of the only instruments humanity has ever placed in a position to study that interaction directly. But then, just as Voyager was continuing to send some of the most valuable data in human history, the spacecraft almost stopped speaking. In 2023, something went wrong. Voyager 1 was still transmitting a signal to Earth. The connection was still there. NASA was still receiving information from the spacecraft, but the information no longer made sense. The data had become corrupted. The spacecraft was alive, but its messages had become unreadable. For 5 months, engineers had a terrifying problem. They were not dealing with a spacecraft that had simply gone silent. That might have been easier to diagnose. Instead, Voyager was still talking. NASA just could not understand what it was saying. The cause was eventually traced to a small piece of memory inside the spacecraft's flight data system. A chip had deteriorated after almost 50 years of operation in space. On Earth, this would be a relatively simple problem. You would open the machine, replace the damaged component, test the new hardware, continue working. But Voyager 1 was more than 15 billion miles away. No engineer could travel to it, no repair spacecraft could reach it in time. The only tools available were radio signals traveling at the speed of light. And even light takes time to cross 15 billion miles. A command sent from Earth could take roughly 22 hours to reach Voyager 1, then NASA would have to wait another 22 hours for the response. One complete exchange could take almost 2 days. Imagine trying to repair a computer when every instruction takes 22 hours to arrive. Imagine sending a command and then having to wait almost 2 full days before you know whether it worked. Now imagine that this computer is nearly 50 years old and one wrong instruction could permanently destroy the mission. The engineers had no room for careless experimentation. Every command had to be planned, every possibility had to be considered. They had to work with a machine that could not be physically touched, opened, or repaired. The problem was not simply, can we fix the chip? The real question was, can we find a way to make the spacecraft work around the damage? Eventually, the engineers discovered that the corrupted code could not simply be restored in its original location, so they moved it. They divided the affected software into smaller sections. They placed those sections in different areas of the spacecraft's remaining memory. Then they rewrote the instructions so the pieces could function together again. It was essentially remote surgery performed across 15 billion miles of space, and somehow it worked. Voyager 1 began sending readable scientific data again. A spacecraft that was designed to last for a few years had survived another crisis. But this time the problem was not just a damaged memory chip. Voyager was also running out of power. And unlike a software problem, this one could not simply be worked around forever. Voyager 1 is powered by radioisotope thermoelectric generators. These devices produce electricity from the heat generated by the natural decay of plutonium. When the spacecraft launched in 1977, its power system produced much more energy than it does today. But radioactive material decays, the available power slowly declines. Every year, Voyager has less electricity to operate its systems, and this has forced NASA to make increasingly difficult decisions. Which instrument should remain active? Which one should be turned off? Which scientific measurements are worth using the remaining power to collect? These are not temporary decisions. Once an instrument is shut down, there may be no opportunity to bring it back. So the mission team is effectively managing a countdown. Every remaining watt matters. Every instrument consumes part of a shrinking energy supply, and eventually the spacecraft will reach the point where there is not enough power to operate its remaining scientific systems. The machine that was supposed to last 5 years is now approaching the end of a journey that has lasted almost 50. But before Voyager goes silent, it is approaching another extraordinary milestone, one that changes the meaning of distance itself. One light day from Earth. A light day is the distance light travels in 24 hours. Light is the fastest thing in the universe. Nothing carrying information can travel faster. So when Voyager 1 reaches a distance of one light day from Earth, a command sent from NASA will take an entire day to reach the spacecraft, and the response will take another day to return. Imagine sending a command to Voyager at breakfast. The spacecraft would not receive it until the following day, and NASA would not know what happened until the day after that. A conversation with Voyager 1 would take days, not because the engineers were slow, not because the spacecraft was slow, but because the universe itself imposes a speed limit. And Voyager is now so far away that even light needs an entire day to cross the distance. This is the point where the journey begins to feel almost impossible. A machine launched in 1977 is still communicating with Earth, but the conversation is becoming slower every year. The distance continues to grow, the power continues to decline, the instruments continue to disappear, and one day the signal will stop. When that happens, Voyager 1 will not suddenly crash, it will not stop moving. There is no atmosphere in interstellar space to slow it down. No road, no engine that needs to keep running, no physical barrier waiting in front of it. The spacecraft will simply continue traveling through the darkness, silently, and attached to that spacecraft will be a message from Earth. The Voyager Golden Record, a gold coated disc carrying sounds, images, and information about humanity and our planet. Greetings in human languages. The sounds of nature, the sound of human laughter, music from different cultures, information about mathematics, information about physics, and a map designed to show where Earth is located in the galaxy. The record was created as a message in a bottle, a message thrown into the cosmic ocean. It was never guaranteed that anyone would find it. It may travel for millions of years without ever being discovered, but that is not necessarily the point. The point is that humanity chose to send something. We looked at the stars. We understood that we were small. We understood that the distance between worlds was enormous, and we still decided to reach outward. Voyager 1 is the physical result of that decision, a machine built by people who knew they might never see its final destination, a machine that has now traveled farther than any human being has ever traveled. And perhaps the most extraordinary part is that the spacecraft is still teaching us. The signal it detected in interstellar space is not a simple answer, it is a question. What exactly is happening in the plasma between the stars? How does the heliosphere interact with the interstellar environment? How much structure exists in the space we once considered empty? How does the environment beyond the solar system change over time? And how much more could Voyager tell us if it had unlimited power? Unfortunately, it does not. Its power supply is declining. Its instruments are being shut down. Its mission is approaching its final chapter. And when Voyager 1 finally becomes silent, humanity will lose its only continuous scientific window into the interstellar environment at that location. A new spacecraft could eventually be built, a new mission could eventually be launched, but reaching interstellar space takes decades. The next generation of explorers will not arrive quickly. That means Voyager 1 is doing something that may not be repeated for a very long time. It is giving us direct information from a region of space that no other active human instrument currently occupies, and every measurement it sends back may be one of the last measurements humanity receives from that environment for a generation. This is why Voyager 1 matters. Not because it discovered aliens, not because it received a secret message, not because the laws of physics suddenly stopped working. It matters because it showed us something far more important. The universe is more complicated than our first models of it. The space between stars is not simply nothing, the boundary of the solar system is not simply a line, the environment surrounding our home is more dynamic than we knew, and one small machine built nearly 50 years ago is still giving us the opportunity to learn about it. Think about how strange that is. Humanity has built computers billions of times more powerful than the systems inside Voyager 1. We have created spacecraft with technology that would have seemed impossible in 1977. We can process unimaginable amounts of information. We can communicate instantly across the planet, and yet the only human-made machine currently sending us direct scientific information from interstellar space is a spacecraft designed before the modern digital age, a spacecraft with primitive hardware, a declining power supply, a signal that takes almost a full day to reach Earth, and still it keeps going. That may be the most important lesson of Voyager 1. The most powerful machine does not always travel the farthest. The newest machine does not always make the greatest discovery. Sometimes the machine that changes history is simply the one that survives long enough to reach somewhere no one has ever been. Voyager 1 was supposed to last for a few years. Instead, it survived long enough to leave the solar system. It survived long enough to send data from interstellar space. It survived hardware failures that should have ended the mission. It survived decades of radiation. It survived enormous communication delays, and now, as its power slowly disappears, it is still sending information home. But eventually, the signal will stop. There will be a final transmission, a final set of numbers, a final measurement, a final message that will spend hours traveling through the darkness before reaching Earth, and then there will be silence. But Voyager 1 itself will continue. It will keep moving through interstellar space. The spacecraft will continue along its path long after the instruments have stopped working, long after the radio transmitter goes silent, long after the last signal has reached Earth, and the golden record will continue traveling with it. A tiny archive of a vanished moment in human history, a message from a planet that once looked up at the stars and wondered what was beyond them. Maybe one day someone will find it. Maybe no one ever will. But the message has already accomplished something extraordinary. It has crossed the boundary. It has reached interstellar space. Humanity did not just imagine the space between the stars. We sent something there, and for now, that machine is still alive, still traveling, still measuring, still sending its signal home. Somewhere in the darkness, Voyager 1 is moving farther away from Earth every second. The signal it sends is already old by the time we receive it. The spacecraft is already farther away by the time we hear what it was saying, and yet we continue to listen because every message is a reminder that something built by human hands managed to go farther than anything before it. A machine that should have died in the early 1980s is still exploring a region of the universe no human being has ever physically entered. And the signal it is sending is telling us that the space between stars may be far more active, structured, and complicated than we once believed. That is what Voyager 1 found, not something supernatural, something more valuable, a universe that refused to be as simple as we imagine. And now the clock is running, the power is falling, the distance is growing. The communication delay is increasing, the instruments are slowly going dark, but the signal is still coming. For almost 50 years, Voyager 1 has been traveling away from Earth, and for almost 50 years, humanity has continued listening. Soon, the spacecraft will have nothing left to say. But until that moment comes, one of the oldest machines humanity has ever sent into deep space is still carrying our questions into the darkness. And somewhere beyond the edge of our solar system, a tiny spacecraft built in the 1970s is still answering them, one signal at a time. Thanks for watching. Please like and subscribe to the channel as the next video will be out tomorrow.